This is a nice quick little reaction and the first in a two-part series. In a previous video we showed you how to prepare benzoin from benzaldehyde using a cyanide catalyst. You can also use thiamine as a more OTC catalyst for that reaction. We're now going to use some of the benzoin and we're going to oxidize it to a compound called benzil. This reaction oxidizes the alcohol to the corresponding ketone, and uses nitric acid as the oxidizing agent. Our setup is a small conical flask with a magnetic stirred bar, and sitting on a hot plate. We'll need to use heating in this reaction, and stirring is also important. Here's our oxidizing agent. 15 ml of 68% concentrated nitric acid. First we pour this into the flask. And now all we're going to do is add 5 grams of our benzoin to the nitric acid. Let's get the stirring dialed up. Towards the end of the addition, even without heating, you should see some brown fumes appearing in the flask. This is nitrogen dioxide being formed as a byproduct of the nitric acid doing its oxidizing job. It's highly toxic and has a lovely delay action, killing you of respiratory failure potentially several days after exposure. So right about now you want to switch on your ventilation. Now that the solid is all loaded, we're going to start heating gently. We want the temperature to get up to about 70 degrees C. As the reaction takes place, brown fumes of nitrogen dioxide escape from the flask. You can see the solid benzoin in suspension in the mixture. Keep heating at 70 degrees for about 15 minutes. Towards the end of this time, if we stop stirring, you can see that most of the solid is gone and the mixture actually consists of 2 layers. Continue to the 15-minute point and then raise the flask up from the hot plate and allow to cool slightly for a few minutes. We've measured out some cold water in order to quench the reaction and precipitate the product. We've got 50 ml here, but we might not use all of it. Here we go. You can see some yellow-colored lumps floating around in the mixture. We're going to leave this to chill down now in order to make sure that all our product is precipitated. It seems to be present in the bottom of the flask in quite large solid lumps, so we used a spatula to break this up a bit, ready for filtering. We filtered this off and got it dry on the pump. Here's our crude product, about 5 grams of a pale yellow solid material. In the reaction, as the benzil forms, it dissolves some of the benzoin starting material and forms the low melting point mixture, which appears as the separate layer that you saw in the reaction mixture. Because of this, some of the benzoin gets petitioned away from the nitric acid and so doesn't get a chance to react properly. So in this reaction there is always some benzoin starting material present in the product. So we're going to need to recrystallize this in order to get a purer product. We're going to use hot ethanol for the recrystallization. Let's get our crude product into the beaker. And let's add some ethanol to start to dissolve it. As it heats up, some of the product is going into solution. Needs a bit more ethanol. Getting there. Here we go. About 15 ml of a nice clear hot solution. Now we're going to slowly drop in some water. This will reduce the solubility of the product in the mixture. Soon we've got a permanent cloudiness forming in the mixture. At this point we stop and allow to cool in order for our product to crystallize out. Here we go. A mass of pale yellow crystals. Filter and get these really dry on the pump. Here we are. Our purified benzil product. We've got 4.8 grams here, which corresponds to a 97% yield. However, there's probably still a little bit of solvent and water in there, and also still a small amount of the starting material as well. We can check this by doing a quick test. In the test tube on the left we've got our starting material, benzoin, and on the right our product. First we add some ethanol to each tube in order to dissolve some of the material. Now we make up a little bit of dilute sodium hydroxide solution in water. Okay, now let's add a couple of drops of this to each test tube. On the left you can see a faint purple color starting to appear. This is the color characteristic of benzoin. On the right is our product, and the mixture has turned a yellow-orange color. We're not too sure why this is. You can see the purple color a bit more clearly held up against the light. Well, if there was a purple color in here we probably wouldn't be able to see it. So we repeated the test only using a very small amount of our product material, again with some ethanol and a few drops of sodium hydroxide solution. The mixture remained yellow for about 20 seconds, and then we've got the purple color. So this definitely shows that our product still contains some benzoin as an impurity. The nitric acid reaction is simpler and more OTC, but you can apparently also perform the oxidation using copper sulfate and pyridine, and apparently this gives a purer product. We've included the reference for this on the screen. We'll be following up in our next video and seeing if we can convert our product to benzoic acid. Stay tuned.